This is a titration example with an outlier. We'll explain what that means. So we've done this titration, KOH and phosphoric acid. Done to the second endpoint. What that means is phosphoric acid is H3PO4, but we're not going to take all 3 protons off. We're only going to take off 2. It says it's done 4 times, and now we have to do it as a regular titration. We're given this volume, so this is likely the volume of phosphoric acid we have in our flask. And we're adding the KOH as we go along. So we end up with 3 very close results in trial 1, 3, and 4. 8.87 is what we call an outlier. And so we're going to get rid of it, and we will average trial 1, 3, and 4. So we add those up, divide by 3, and we see we're going to be using 8.27 milliliters. Once you've done that, it becomes a fairly straightforward beast, except for the equation. H3PO4, we only use 2 KOHs because we're taking off 2 protons from the H3PO4. So we're dropping down to 1 HPO4 there, and 2 potassiums have gone on there, and we've made 2 molecules of Wawa. If you don't want to include the K, if you'd rather get rid of it as a spectator ion, you can write it out. It has no effect in terms of change in reaction. It's still a 2-to-1 deal. So we're going to take our concentration, multiply by our volume, which we have to have in liters. Otherwise we get millimoles. Get our moles, then we multiply by 1/2, so we end up with half the amount. Now we can divide by our volume in liters, and we will arrive at our concentration of 0.232 big M. So that's how you deal with an outlier. So the 2 things were the outlier, and then also this is a kind of fancy reaction where we just showed the removal of 2 protons. So those would be the 2 biggies for what we care about in this video.